Imagine a hotel. This isn't just any hotel, it's Hilbert's Grand Hotel, a magnificent establishment boasting an infinite number of rooms. Every single room is occupied. A neon sign flickers outside, proclaiming no vacancy. An air of impossibility hangs in the air, a challenge to the very notion of capacity. This is where our mathematical journey begins, a dive into the fascinating world of Hilbert's infinite hotel paradox. This thought experiment, conceived by mathematician David Hilbert in the early 20th century, throws our everyday understanding of numbers out the window. It forces us to confront the strange and counterintuitive nature of infinity. In the realm of the infinite, the usual rules of addition, subtraction, and even logic itself are twisted into fascinating new shapes. The paradox starts with a simple question: what happens when a new guest arrives? In any ordinary hotel, the unfortunate latecomer would be turned away, but Hilbert's hotel is no ordinary establishment. Here, the impossible becomes possible. Through a clever manipulation of infinity, the hotel can always accommodate more guests, no matter how full it seems. The arrival of a single new guest sets the stage for the mind-bending logic of Hilbert's hotel. At first glance, accommodating this new arrival seems impossible. Every room is taken. However, the solution is surprisingly simple. The hotel manager asks each guest to move one room over. The guest in room 1 moves to room 2, the guest in room 2 moves to room 3, and so on. This creates a vacancy in room 1, allowing the new guest to check in. We've just witnessed the magic of infinity in action. By shifting each existing guest by a finite amount, we've created space within the infinite. The situation becomes even more intriguing when a bus carrying 40 new guests arrives. Again, the solution lies in shifting the existing guests. Each guest moves 40 rooms down the line. This vacates the first 40 rooms, providing ample space for the new arrivals. The pattern is clear. No matter how many finite guests arrive, the hotel can always accommodate them. Now imagine an infinite convoy of buses arrives at Hilbert's hotel. Each bus carries an infinite number of passengers. This is the ultimate test, a scenario that seems to push the limits of even infinity itself. Can the hotel possibly accommodate an infinite number of infinite groups? Surprisingly, the answer is still yes. The solution lies in understanding a fundamental concept about infinity. There are different sizes of infinity. The infinity we've been dealing with so far is called countable infinity, denoted by the symbol Aleph 0. It represents the set of all natural numbers, 1, 2, 3, and so on, a set that is infinite but can still be counted, even if it takes forever. To accommodate the infinite convoy, the hotel manager employs a clever strategy using prime numbers. Each existing guest in room N is moved to room 2N. This vacates all the odd-numbered rooms. The passengers on the first bus are then assigned the odd-numbered rooms. The passengers on the second bus are assigned to rooms that are multiples of 3, the third bus to multiples of 5, and so on. This pattern continues, with each bus assigned to rooms based on the powers of prime numbers. Since there are infinitely many prime numbers, there are enough rooms for all the buses. Hilbert's hotel paradox reveals that the infinite is not a single monolithic concept. Countable infinity, as demonstrated by the hotel's ability to accommodate an infinite number of guests, is only the beginning. There are in fact higher orders of infinity. For example, the set of all real numbers, including fractions and irrational numbers, is considered uncountably infinite. These higher infinities are so vast that even the clever strategies used in Hilbert's hotel wouldn't work. Hilbert's hotel is not just a mathematical puzzle, it's a powerful metaphor for the boundless nature of infinity. It forces us to confront our intuition and embrace the strange, counterintuitive reality of the infinite. It reminds us that our understanding of the universe is constantly evolving, and there will always be new mysteries to unravel, new paradoxes to ponder, and new frontiers of knowledge to explore.